So for no good reason, I'm going to do this assignment backwards. This is quadratic formula. All right, 16, an astronaut on Mars tosses a rock straight up from a height of 6 foot and an initial velocity of 24 feet per second per second. On Mars, the equation relating time and height is height as a function of time is negative 16 t squared plus v subscript 0 t plus h subscript 0. So compare and contrast the equation for Mars to that of Earth. And Earth is height as a function of time is blah, 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 negative 16 t squared being the big thing. Why are the equations different? You'll notice they're pretty much the same with the exception of this. And the reasons they're different is pretty simple. Earth has higher gravity. The first part of the equation, the negative 6t squared and negative 16t squared, they deal with the pull of gravity. Now, Earth has a higher gravity. So it's going to pull things down faster. So that's the difference. All right, write an equation for Mars by substituting in the initial velocity and the height. So height as a function of time is in Mars, negative 6t to the second. Plus, it says the initial velocity is 24 feet. And an astronaut, and we don't add, I didn't say the height, did I? I'll modify that, let's say from 5 feet. Let me go back here to that document and edit that 5. Doesn't say the initial height. Oh yeah, it does. 6. Never mind. Tired apparently. It's in the text. There we go. From a height of 6 foot. All right, how many seconds will the rock be 10 feet above the surface? You need to at least write this down. You're replacing the height with 10. And we're going to use Desmos to solve it. You know you're allowed to use Desmos on your end of course test. So we're going to use Desmos to do it. Apparently I have no internet. Let's see here. We put a 10 on the left. It's kind of like doing a calculator, y1, y2. And we have negative 6x to the second plus 24x plus 6. We're just going to scroll up, and you'll see we get two answers here. We have that answer, we have that answer. So after how many seconds will the rock be 10 feet above the surface? It'll do that for an interval of time, actually, so long as the time is stuck between these two numbers. So let's say 0.1743 less than time less than 3.8257. That's how you write the answers in inequality. Now, as an interval, 0.1743 and 3.8257. So as long as I'm between those two times, I'm 10 feet above the surface. How many seconds will it take for the rock to return to the surface? So in Desmos, we're going to place that 10 with a 0. I have to drag back down to it. I've got two answers. I've got the extraneous answer over here where time is negative, and I have the real answer here, 4.236. 4.2361. On Earth, how many seconds would it take for the rock to return to the surface? So on Earth, our equation would be 0 equals negative 16 t to the second, because we're talking about Earth's pull of gravity, 32 feet per second per second. Still have the initial velocity of 24 and still 6 foot of height. So anyways, back to Desmos. Just going to change that to a negative 16. And you'll see the rock came down a heck of a lot quicker. 1.7183 seconds. 1.7183. I strongly encourage you to play around with Desmos on your own time. I mean, check your work with it. It's really easy to check. Get accustomed to looking at graphs. It's not going to kill you. Let's see here. I guess I'll do 2 of these 5. It says find the value of k that will cause the equation to have a given number of solutions. So let's look at 15. The imaginary solutions happen if b squared minus 4ac is less than 0. That's how they happen. So here I have an a value of k. I have a b value of negative 3. So negative 3 squared minus 4 times a, which is k, times c, which is 4, is less than 0. And I just crank out some math. You know, a negative 3 squared is 9. And I don't know why I put c. It's supposed to be 4. I have a 9 minus 4 times 4 is 16. 16k less than 0. You just move your 9 to the other side. Negative 16k is less than negative 9. And then you divide out your negativity. Now, when you divide an inequality by a negative, the sign flips. So k has to be greater than 9/16. I would really prefer if you guys would use interval notations. The interval on this would be 9/16 all the way to positive infinity. Usually takes 3 tries for me to get the right one. Nope, it's going to take 4. All right. I'm going to let you all try and do 13, 14. The ones above say use the discriminant to identify the number and types of solutions for each equation. Again, the discriminant is the b squared minus 4ac part. So I'm looking at this one, I'd have a 7 squared minus 4 times a, which is 1, times c, which is 11. And I'd have 49 minus 44, which is 5. Now, since the discriminant value is 5, since 5 is greater than 0, I have 2 real, unique solutions. They are real and they are different. All right, like I said, I did 2 of those for you. Use any method, aka factoring quadratic formula. I feel like 10 is going to take the QF. I feel like 9 factors. I'm not going to do either one of them for you. The rest of this is just quadratic formula. They all do 5, but it's just the QF. You know, first things first here, we shift everything left because we want to be set equal to 0. Pretty good chance this one has imaginary solutions. Real good chance of it. Sing yourself, and please replace the voice in your head with your own voice instead of mine. It doesn't need to be me saying the quadratic formula, but it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. And hopefully you're not that kid who can't pick out A, B, and C. But that kid exists every year, and we wouldn't expect this year to be any different. You just got to wake up, man. Wake up. All right, so we're plugging in. Opposite of a positive 8 is a negative 8, plus or minus the square root. And a lot of you guys are button pushers, so always put that b term in parentheses. Minus 4 times a, which is 5, times c, which is 4. And it's all sitting pretty over twice 5. and we just do some math. You're welcome to do this in a calculator, but this is 64 minus what, 90? 80. That's 80. 4 times 5 is 20. Yeah, 80. And, 64 minus 80 is negative 16. Both pieces over 10. Now, the root of negative 16 is going to be plus or minus 4i, because the root of negative 16 is equal to the root of a negative 1 times the root of a positive 16, and the root of negative 1 is I, and the root of 16 is 4. We don't say I4, we say 4i. So I have negative 8 over 10 plus or minus 4i over 10, and I want this form a plus bi. Negative 8/10 reduces down to negative 4/5, and 4i over 10 is going to be plus or minus 2i over 5. So there you go. Like I said, easy peasy, lemon squeezy. If you want 1 and 2, you can get those straight from your notes. Straight out of your notes. All right, so I'm only going to do one more of these. 3 would actually factor. It's going to be x minus 5 written twice. That's a perfect square, but anyways, you're supposed to use a QF. And let's see what happens if we do it. Anyways, I know it factors. Your A is 1, your B is negative 10, and your C is 25. And again, your formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So opposite of a negative 10 is a positive 10, plus or minus. Now here's something a lot of y'all will make a mistake on. You might wrap it on paper, but you'll forget the parentheses in the calculator. Can't fix that. Minus 4 times a, which is 1, times c, which is 25, all sitting pretty over 2 times 1. Now what's in this radical? In this radical, you've got 100 minus 100, which is 0, and the square root of 0 is 0. That one bothers kids. Kids want the square root of 0 to be something else, but it's 0 because 0 times 0 is 0. And I can't fix that. We have 10 plus or minus nothing over 2. Now 10 over 2 happens to be 5. This is 5. This is a repeated real solution. It actually happens twice. The reason I know it happens twice is because we have a square. We call this a repeated real solution. Anyways, that's all I'm doing on your homework. Again, this stuff right here is straight from your notes. You just need to look at your notes. That's all you need to do. And if you don't know the quadratic formula, like, where have you been? What is wrong with you? We've been doing it. All right, there's 2-7. Enjoy.